Hello guys, in this video I will solve 3 sample questions of a quantitative part of GMAT exam. So let's go to the first one. It says that if Mel saved more than $10 by purchasing a sweater at a 15% discount, what's the smallest amount the original price of the sweater could be to the nearest dollar? To begin this question, I warn you that the question say anything about the price of the sweater. I don't know how much cost the sweater, so I will call, for example, X the sweater's price. I also know that Mel received 15% of discount, so I know that the discount that Mel received is 15% of X. And once the question said that Mel saved more than $10, I know that 15% of X must be greater than 10. So we got an inequality here. And to solve this inequality, I will begin dividing both sides by 5. So if I divide 15 by 5, for example, I got a 3. And if I divide 10 by 5, we got 2. So we have that 3x here must be greater than 100 times 2 is 200. So this implies that x must be greater than 200 divided by 3, okay? So if we divide 200 by 3, we get approximately 60.60. If we round to the nearest dollar, we got that this value here must be 67. So the correct answer of this question is the letter B. Let's go to the second one. In this question, we have that 5 machines at a certain factory operate at the same constant rate. If 4 of these machines operating simultaneously take 30 hours to fill a certain product order, how many fewer hours does it take all 5 machines operating simultaneously to fill the same product order? Okay, this question deals about machines and about the amount of hours that machines do a certain job. We know that 4 machines do the job in 30 hours. Great. And we have to find out the amount of hours that 5 machines do the same job at the same constant rate. So I have to find out the amount of hours that 5 machines do the job. I warn you that if we increase the number of machines here, the number of hours that those 5 machines do the same job have to decrease. If we increase the number of machines, the number of hours, the amount of hours to do the same job, there's no way this number of hours have to decrease. So to put the proportion about this question in a correct way, we have to consider that 4 over 5 must be equals to x over 30. Instead, to consider 4 over 5 equals 30 divided by x. We invert here because the quantities involved in this question are inversely proportional. Okay, so we got that 5 times x here is 5x, and 4 times 30 is equals 120. So this implies that x must be equals to 120 divided by 5. 120 divided by 5 is 24 hours. So 5 machines do the same job in 24 hours. We know at the beginning that 4 machines do the job in 30, and 5 machines, we got that those 5 machines do the job in 24 hours. So the answer to how many fewer hours does it take 5 machines operating simultaneously to fill the same production is 30 minus 24, we got 6 hours. So the answer of this question is letter C. Let's go to the last one. In this question, we have that Stephanie has 2 and 1/4 cups of milk on hand and make 2 batches of cookies using 2/3 cup of milk for each batch of cookies. So I know that Stephanie uses 2/3 cups of milk in each batch, but she prepared 2 batches of cookies. So the amount of milk that Stephanie used is 4/3 cups of milk. In the beginning of the question said that Stephanie has 2 and 1/4 cups of milk on hand. And in the ending, note that the question asks us which of the following describes the amount of milk remaining. So the remaining milk must be equals to 2 and 1/4 minus the amount that she used. That's 4/3 of cups. Okay, to perform this subtraction here, we put this mixed fraction in a non-mixed form. To do that, it's easy. So we just have to keep the denominator and we have to multiply the integer part by the denominator. So we have 2 times 4 is 8, and after that we sum the value with the numerator. So 2 times 4 is 8, 8 plus 1 is 9. So 9/4 minus 4 divided by 3 is equals, if we consider the least common multiple of 4 and 3, the value is 12. And to do this calculation, we will divide the least common multiple by each denominator, and after that we have to multiply to the numerator. So 12 divided by 4 is 3. 3 times 9 is 27. And 12 divided by 3 is 4. 4 times 4 is 16. So the result, the remaining amount of milk is 11 divided by 12 cups of milk. Great. Note that we have to find the correct answer. And I tell to you that the correct answer is the letter C. Why is that? Note that this value, 11 divided by 12 cups, is in fact between 3 divided by 4 cups and 1 cup. Why? Because 3 divided by 4 is the same if we multiply numerator and the denominator by 3, we got 3 times 3 is 9, and put a 9 here, and 3 times 4 is 12. Okay, so the letter C says that the value that we found is between 9 divided by 12, and it had to be less than 1 cup. This 1 cup, I can represent 1 as 12 divided by 12. Okay, in fact, note that this value right here, 11 divided by 12, is between 9 divided by 12 and 12 divided by 12. So the correct answer must be letter C. I hope you enjoyed this video and see you in the next ones. Bye.
Number 29. Now there is our individual Susie, and Susie's discount footwear, it is all about, sells all pair of shoes for one price and all pair of boots for another price. Now on a particular day, and it is given to be Monday, the store sold 22 pairs of shoes and 16 pairs of boots for these. This is the dollars, okay? This is the sales, okay? And now on Tuesday, 8 pairs of shoes and 32 pairs of boot, and this is the total amount that has been received after the sales. So the question is, how much more do pair of boots cost than pair of shoes at Susie's discount footwear? So we need to find out the price of the two, and then we need to figure out that by how much the price of other is greater, something like that. So one approach to this question is to set up two equations, and then after doing it, the next step is we will eliminate. We'll have two equations, and here there are two unknown, that is the price of boots and the price of shoes. So we will eliminate one variable and then we will solve for the other. So I know you are a little confused of how we are going to work. So let's see how we are going to do it. So we'll form the two equations first. So if I'll take small s to represent the price of, small s to actually represents the price of shoes, and b represents the price of boots, then we can form the two equations. What are the two equations? First is 22s plus 16b is given, the sales value is 650, and then you have 8s plus 32b is equal to 760. Now I'll be eliminating b because I don't like that alphabet. You can do anything you want to. So to eliminate b, I'll multiply both sides of the, so if I mark this as first equation and mark this as second equation, so to eliminate b, I'll multiply the first equation both sides by a factor 2 and then subtract. I'll get one result after multiplying 2, and then after the result I'll subtract, or I'll reduce it, subtract the second equation from the modified first equation. Okay, so modified first equation. So you will get something like this. You will get 44s, this is the first equation, plus 32. Okay, I will give you the answer directly. So it will become, after all the multiplication and division, you will get 44s minus 8s plus 32b minus 32b, 1300 minus 760. So you can eliminate these two. So you will get 36s becomes equal to 540. So you will get s is equal to 15. This will be in dollars because s is nothing but actually represents the price of the shoe. So the cost of the shoe is nothing but $15. You can plug this value of s in equation 1 or 2 and can get the corresponding value of b. So if you plug it in one of the equation, you will get b to be equal to $20. However, this is not the answer. They have asked us to find out by how much more do the pair of boots cost than pair of shoes. These are the price of boots, these are the price of shoes. So boots cost $5 more. That means B will be the correct answer. That means option B is the correct answer to this particular question. We will now move on to question number 3. Question number 3 says, I'll just clear the page so it is convenient for me. Okay. For any three given numbers, which of the following is always equivalent to adding three numbers together and dividing the sum by 3. Okay? First is given to be ordering the three numbers numerically from highest to lowest and then selecting the middle number. Okay. 2 says dividing each of the numbers by 3 and then adding the result together. And 3 says multiplying each number by 6. This is the factor they have used. Adding the resulting product together and then dividing by the sum by 9. So let's do it. So we'll choose any three numbers and test them on statement 1, 2 and 3. So you will quickly find out that 1 and 3 are not always true. 2 is always true. Why? Because mathematically the process in the question are doing the same thing. That means we are summing the numbers and we are actually dividing them then by a factor 3, which is actually asked in the question. That means only the state here 2 is correct, so that means we have to pick option number B. Let us move on to the next question. The next question is related to company ships. So it says that a hat company ships is hat individually wrapped in 8-inch by 10-inch by 12-inch boxes. So you have length, height and width. Now each hat is valued at this is the price. Now if the company latest order required a truck with at least 288 followed by 000 cubic inches of storage space, in which you require to ship the hats in their boxes, what was the minimum value of the order? So we need to find out the answer in terms of dollars. So let's do this. So we have an 8 into 10 into 12-inch box, and this particular box, if you multiply the three factors here, you will get the answer to be 960 cubic inches. Okay? Now we have been also provided by the truck storage space, and it is given to be 2 followed by 88 followed by 000 total cubic inches, and this must be divided by 960 cubic inches per box, and this is equal to 300 boxes. However, this is not the answer. Now we will consider actually the cost side or the value side of each box, and we will multiply to get the value of the order, minimum value of the order. So we will just multiply 300 with 7.50, which is the cost per hat, and this value equals to $2250. That means the correct answer to this particular question will be option number E. So we'll pick E as our answer. Next or lastly, we will move on to question number 32. This will be the last question we will be solving, and then we will wind up today's tutorial. The question says, Chauncey, which is our individual, is an English bulldog and received this number of votes in the Mr. Bulldog USA competition. Now giving him approximately 20% of the vote. Now approximately what percent of remaining vote would have been needed to receive in order to win 30% of the total votes? Now, so let us analyze this. So if at all 1618 was 20% of the vote, then there were approximately 8090 votes. Now this we will get by 16. So we can say approximately he has received this number of votes, or which we have achieved by getting the percentage. So this will be by 0.2. So we will get 8090. Okay. Now 30% of 8090 would actually become 2427. Now this is what you want now, and this is what you have received. So you require 809 additional votes. Okay, and this number of votes is required by the individual, and which will actually be needed in order to reach him to the 30%, to win 30% of the total votes. So then we have, in percentage we can get it, 8090 by 1618 is equal to 0.125, which is nothing but 12.
All right, how'd you do? Well, I won't give you the answer yet, but hopefully you picked up on the fact that it is a statistics question. Now, what in the heck is a standard deviation, right? What does it even mean to figure out how many of these listed amounts are within 1.5 standard deviations of the mean? All right, well, there's a couple things going on here. So we have this vending machine, and it's spitting out cups of coffee, 1,000 of them, right? And we can represent the distribution of those cups of coffee with what's called a normal distribution. You can think of it as a bell curve, if you remember that from high school. And basically, here's what a bell curve does. It shows you how the different iterations of whatever is being tested are distributed around the mean. And the mean is smack dab in the middle. In other words, 50% of the outcomes are going to be less than the mean, and 50% of the outcomes are going to be more than the mean. Now, it says it's trying to dispense 8 ounces of coffee, but unfortunately, it's not quite accurate, right? Because the mean, the average is 8.1 ounces. And so all that means is that 8.1 ounces is the average, it's the mean. So 50% of them are going to be less than 8.1 ounces and 50% are going to be more than 8.1 ounces. Now, how much more? That is determined by what we call the standard deviation. A standard deviation is simply a representation of the spread around the mean. In other words, some cups of coffee are going to be more than 8.1. How much more? Well, we might not know until we do some calculations, and the good news is you don't have to do the calculations, they've already told you. Right? One standard deviation is going to be 0.3 ounces, and what that means is that one standard deviation, we call this a standard deviation, we're just going to draw it with a line, are going to be 0.3, so plus 0.3 ounces more than the average of 8.1. So if you add 0.3 to 8.1, you get 8.4. And likewise, some of the cups of coffee are actually going to be less than 8.1. By how much? By 0.3 less than 8.1, or 7.8 ounces. Now, how many of the cups of coffee are going to be less than 8.1 by one standard deviation? Well, you don't have to worry about that. I mean, technically, it's 34%, right? This is something I teach in the videos and may be useful on really hard questions. In other words, 68% of all of the cups of coffee are going to lie within one standard deviation, either above or below the mean. So the question's not asking you to know that. It's simply recognizing that one standard deviation less is going to be 7.8 ounces, and one standard deviation more than the average is going to be 8.4 ounces. Ah, but that's not what the question's asking. It's asking how many are within 1.5 standard deviations. Well, how do we get a half a standard deviation? Well, it's just half of that 0.3 or 0.15, right? So let's add an additional 0.15 onto the 8.4, and that should give us, right, 1.5 standard deviation, shouldn't it? Because one standard deviation is plus 0.3. An additional plus 1.5 would give us a total of 1.5 standard deviations. So 8.4 plus 1.5, that would be 8.55 on the positive side, right? But on the negative side, we need to go down another negative 0.15, right? That'll get us down to negative 1.5 standard deviations. And if you do that subtraction, it's 7.65 ounces. And so all of the cups of coffee between 7.65 and 8.55 lie within that 1.5 standard deviations on either the positive side or negative side. Does that all make sense? I really hope that makes sense, because at this point we have determined the range of 1.5 standard deviations, right? 1.5 standard deviations to the low side, positive 1.5 standard deviations to the plus side, and any of these cups of coffee that fall within that range count. So how many of them are there? Well, now it's just a matter of counting. How many of the 12 listed are within that range? Is 7.51 within that range? No, 7.51 is less than 7.65, which is the low end of our range that we determined, so 7.51 is not. Is 8.22? Yes, it is. 7.86? Yes, it is. 8.36? Yes. Yes. 7.83? Yes. Yes. 8.01? Yes, that's almost the mean. 7.73? Yes. 8.25? Ooh, 8.53 is close, but remember 8.55 is the upper limit, so 8.53 as well. Heck, 11 of the 12 cups of coffee fall within that range. So the answer, therefore, is answer choice, where do we go? Answer choice E, 11. Well done if you got that. So it's not rocket science, but you do have to understand A, what a mean is, and then B, what a standard deviation represents. It represents the spread around the mean, and it can absolutely be determined with an actual numerical value, and the test makers will likely give you that. You're not going to have to actually calculate standard deviation on the GMAT, but you will have to know what to do with it and how to interpret it and what it means. Now you know how to do that, which puts you in a better position to go out and dominate the GMAT. Difficult question. I can understand if you had some issues with it, but let me show you some things. Even if you think you got the right answer, and bear with me, let's see if you noticed a couple of things that would have enabled you to save some precious time that'll enable you to get more right answers down the line. Obviously, you start this question by writing out the area formula for a triangle, because that's what we're trying to find. No, it tells us the area. We're trying to find z, but we got to start with the area. So it tells us, that the area is 24. Well, we know the area is 1/2 base times height. Well, in this case, the base or the height is x, I guess. I wrote this backwards, and the base is y, but that doesn't really matter. And we know that that's going to equal 24. And then we want to get rid of fractions, so let's multiply by 2. So we recognize that xy is going to equal 48. Now this is crucial, because at this point, this is where you could go a totally different path and get a right answer by saving yourself a lot of time without having to do the math. You may have ventured down the path of actually doing the math. And my purpose isn't to teach you how to do that, but let me just scratch it out real quick. Obviously, it tells us that x equals y plus 2, so we could substitute that in, and we could say that, so y times y plus 2 equals 48, and then we say, uh-oh, looks like we got some quadratic equations going on, where y squared plus 2y. Let's subtract the 48 to the other side, because we know we like to set quadratic equations equal to 0 so that we can find the factors, so that we know it's y. Let's see, 6 times 8 is 48. It's got to be positive 8, and then negative 6, so y minus 6. Equals 0, and then we can solve for y, right? Y can't be negative, so y is going to have to be positive 6. All right, if you didn't understand that, go check out my lesson on algebra and quadratic equations. But that would be the long way of going about it. And then we could say, okay, well, x is y plus 2, so that means x equals 8. How could we have done this faster? Well, what we could recognize is that once we see that x times y has to be 48, how many possible combinations are there even, right? Well, we could have 1 times 48 equals 48. So those are possible values for x and y, right? I mean, that's essentially what I'm doing. We could do 2 times 24. It could be 3 times 16. It could be 4 times 12, right? 5, 6. It could be 6 times 8, right? Those are the possible values. And what we know about the rules of triangles is what? And this is what I'm really getting at. The hypotenuse has to be longer than the longest side. So let's say this weren't drawn to scale, and we had a triangle that looked like this. You know, super skinny down here, that's only 1, and way up here is 48, right? We're assuming these dimensions. What does that mean about the hypotenuse z? Well, z is going to have to be at least as big as 48, so it's going to have to be greater than 48. What do we notice about the answer choices? Even the biggest answer choice at 10 is not even close to 48, so that's not right, right? And actually, we know that with problem-solving questions, we want to assume the figure is drawn to scale unless otherwise indicated. So it's probably a pretty good guess that the dimensions are going to be 6 and 8. And what do we know at this point? We know that the hypotenuse has to be longer than even the longest side. Well, the longest side here is 8. The short side is 6. We recognize that answer choices in GMAT problem-solving questions are in either ascending or descending order. So that enables us to eliminate A and B as well. Now we've gotten to answer choice E so much faster. A lot faster than if we did all of these steps doing quadratic equations. Maybe you got hung up here figuring out the factors, and you spent an extra 30 seconds to a minute solving for x and y. This is a different solution, and that's the type of thing that you want to do to save yourself those precious seconds. Worst case, let's assume you went through all of that doing quadratic equations to solve for x and y, and now we know that we do have 6 and 8. Here's the other thing. Either A, you recognize that the hypotenuse has to be longer than the longest side, which leaves us with answer choice E, as I said, or what did I teach about right triangles? And if you haven't watched it yet, go check out our triangles video. Because it's crucial that you know right triangles inside and outside, but you recognize that this is in essence a 3, 4, 5 right triangle. What you don't want to start doing is the Pythagorean theorem. If you started ever, when you were doing this problem, 6 squared plus 8 squared equals z squared, and then you start doing that and solving for z, you have missed something. Remember, I always say, if you're doing the Pythagorean theorem on the GMAT, you've probably missed something. Not always. Sometimes you have to do it, but here, what have you missed? You've missed the fact that this is a scaled-up version of a 3, 4, 5 right triangle, which is a common right triangle you should know. Another way that you can save some time and figure out right away that the hypotenuse is 10 without actually having to do the math of the Pythagorean theorem. So lots of different things going on in this problem, all of which put you in a position to save precious time, not by making careless errors, but by looking for shortcuts. And at some point in the process, maybe right here, once you recognize that x times y equals 48, you can jump to the head of the class. You can start to eliminate wrong answer choices just by using a little bit of logic and save yourself those 30 seconds, maybe even a minute or more that you can now apply on later questions, all of which is going to add up to a higher GMAT score, enabling you to go out and dominate the GMAT.